So I knew that some of you would be going to Beta Club convention on Tuesday, so I went ahead and decided to make this video early in case that you want to watch it early and do the work before then. I will not be at school tomorrow. The sub has the worksheet that you need to do the homework on that we'll be working on Tuesday. So if you're going to be going to Beta Club and you'd like that worksheet, go ahead and get it on Monday. We're talking about absolute extrema. Which pretty much means absolute maxes and absolute mins. If you have a graph that looks like this right here, there's no absolute extrema. There is a local max and a local min, but because the graph keeps going up forever and down forever, there's none that's higher or lower than the rest of the graph. If you look at this graph, there's no absolute min because the graph keeps going down forever, but this is the location of the absolute max. Because that point is higher than all the other points. Now, if you have a graph that's like this, where it doesn't keep going forever, and it just stops, this would be the absolute max. This would be where the absolute min is located, because those 2 points are higher and lower than the rest of the graph. And even though there's another little max and min here and here, those two are the absolute ones because they're higher or lower. So what we're going to be doing is you can look at the graphs and figure it out, but also we're going to be looking at the equations. When you look at the equations, you have to make the number line, find the maxes and mins, and then figure out the absolute one. So let's say that you have y equals x squared minus 2x plus 2. And sometimes they'll give you an interval and sometimes they won't. But in this case, we're given the interval from 0 to 3. So, first of all, you would find the max and mins like normal, find the derivative, set it equal to 0, figure out the zeros of the derivatives and undefined places if there are any. Make a number line. Decide whether, using f prime, since this was from the derivative, decide on your negatives and positive. This one happens to be negative and then positive. And what that tells me is that there's a max at x equals 1, since f prime of x changes negative to positive. Now, once you figure out whatever's going on, and you know what, that was supposed to be a min. Since it's going negative to positive, that should be a local min, not a max. Now, once you figure out what's going on the graph, then you can look at your endpoints. So we know that there's a min at x equals 1. So in our mind, you don't really have to draw this, but it helps me. I know that the graph looks something like that. Technically, since there's a min and the graph keeps going up on both ends, that's the only min. That means that that has to be where the absolute min is located. The max is going to be located either here or here because of the way the graph is shaped. So before you can go on to find out which one is the absolute max, you need to say that max is at x equals 0 and 3, and explain what f prime is doing or what f is doing. And I know that f of x is decreasing and then it's increasing. So do the first one like you normally do. Then do the second one just based on what's going on. Since that's what f prime is doing, that's what f is doing. And then you can explain what's going on the endpoints. So after that, you take all of the x values you found, the maxes and the mins, and you find the y values. You plug 0, 3, and 1 into the original equation, into the y equals x squared minus 2x plus 2. You get 2, 1, and 5. I already know that this is the absolute min. You don't have to explain anything because you've already explained why it's a min. and we're just looking at the y values. So 1 is the absolute min. 5 is the absolute max. And you don't have to explain anything on that because we've already figured out and explained that these two are maxes. So to figure out the absolute one, you look at the y values, the y value that's bigger, that's the one that's the absolute. If it just says where is it located, you would say x equals 3 would be where the absolute max would be located. But if it says what is it, then I'm talking about the y values. Okay, let's look at another one. Alright, so first of all, find the derivative. Set it equal to 0. Solve. So on my number line I have 0. I have -1. I have -1. Plug your values into the first derivative. And so what I know is that there's a max at x equals -1. Since f prime of x changes negative to positive, I know that there's a min at x equals +1 because f prime of x changes this is supposed to be negative to positive, and I realize I made a mistake. This is supposed to be positive to negative. Now let's think about the graph a minute. This is about f prime of x. So that means that f of x, and you just need to say it, that way you can explain the endpoints. F of x decreases, increases, decreases, and then increases. So I don't know exactly what the graph looks like, but I know that it starts off getting bigger, and then it gets smaller, and then it gets bigger again. That right there tells me that at -2, there's a min, and that at +2, there's a max, because at +2, it's higher than the points before it, and at -2, it's lower than the points before it. So this part right here just tells me that, and you just need to say it. You need to say f of x does this, and that indicates what's going on at the endpoints. So then you make a number line. I'm going to put my mins together, and I'm going to put my maxes together. And I've already determined why they are mins and maxes. I now just have to figure out which one is which. So at -2 it's -57, -1 is 1, at 1 it's -3, -1 is 1, and 2 is 55. So I know that my absolute, you also might see the word global, max is at 55. Or is 55, and the absolute or global min is at -57, or it is -57. Alright, if I have f of x is 1 over x plus 2, if I do the derivative, I get that the derivative is -1 over x plus 2 squared. And I'm going to find my maxes and mins on the interval -1 to 3. So if you find the zeros, this particular graph never equals 0. Remember, you set the top equal to 0, that tells you if there's any zeros, and set the bottom equal to 0. You don't get anything on that one. You get x equals -2. You take the square root and subtract 2. So I'm going to put -2 on the number line. Remember, we're comparing f prime of x, and thinking about those things, notice on the derivative right here that no matter what number I put in for x, the bottom's going to be squared, so the bottom will always be positive. Top's always negative, so that means that no matter what number I put in, I'm going to get negative. Now you can check them to see that, but you're going to get negative both places. What that means is that there's not any local maxes or mins. Okay, our interval is from -1 to 3. Since f prime of x is always negative, that means that f of x is decreasing. So think about that a second. Decreasing means we have a graph that's coming down. It might be doing other stuff in the middle, but basically it starts high and comes low. It's decreasing. So what that means, if this is -1 and this is 3, that means that there is a max at x equals -1, and there's a min at x equals 3. And because we're talking about an interval that's not increasing forever, then you just make your little xy chart, put -1 and 3 on it, plug those back into the original equation. -1 has a value of 1, 3 has a value of 0.2, and because there was a max at x equals -1, the global or absolute max is 1, and since there was a min at 3, the global or absolute min was 0.2. So to sum it up, if you're looking at an equation, you find the derivative, set it equal to 0, make a number line, look for any maxes and mins, like where f prime of x changes sign, describe it, like that there's a max because f prime of x changes from positive to negative. Then describe the shape of the graph. Because if you describe the shape of the graph, you know what's going on at the endpoints. Once you know what's going on the endpoints, you make a t-chart. The t-chart is the chart where you have your x's and y's, and then the y values give you the actual max or min. Be sure to ask the sub for the worksheet, and I think there's 11 problems on it that will go with this, and this is what we'll be doing on Tuesday.